7. All right, so we're starting physics part 2, which will be motion graphs and calculating speed. So get your brain turned on. All right, so looking in week 7 on Google Classroom, okay, we'll come back to these things. You need to know what the content is before you start practicing them. So as always, you can go to Science Notebook in Google Classroom. I would say go ahead and copy this down first so you can focus on my explanation. So at this point, you could push pause, copy this down, and then come back and play, and I will explain these notes in just 1 second. Okay, but don't forget this is here, and then I'll also explain the motion graphs practice, which will be your second part. Okay, so looking at this, right, you should have already pushed pause and copied it down. All right, we're doing motion graphs. What helps if we know what motion is? It's one of those things that we know it, but when someone puts you on the spot and like, so what's motion? You're like, when stuff moves, sort of, right? So we need to have our science definitions to go with these things. So it's the movement of an object. And we say object because it can be a cheetah, it can be a paperclip across the desk, whatever. It's also known as a change in position. And don't forget that triangle, remember it's the Greek letter delta, it's what scientists use to represent change. So that's something you need to be incorporating in your brain and incorporating into your notes. Right? The motion graphs that we will focus on are distance versus time graphs. In 8th grade, you'll take this up a level and do speed versus time graphs. So you'll build on what we're working on now. The thing about distance versus time is that is basically speed. All right, so after your test, last time we had class, you were supposed to look at the graph games and move the stick figure to match the pattern on the graph. Okay, so that blue line you created is the speed of Stickman and whether he was going away from home or coming back home. Now, as far as these graphs go, you got to know where to put what. Your distance is going to go on the y, your time is going to go on the x, and don't forget that we learned about dry mix. You can flip back your pages in your science notebook to our variables notes and our graph notes. Everything from the beginning we will continue to come back to. Something else to be aware of is that sometimes distance is referred to as position, because distance kind of conveys that you're on the land going from point A to point B. But with all of these things, think about jets flying across the ocean to another continent, or us launching spacecraft to go and orbit the Earth. Not everything is in a straight line and very simplistic. Right, but these two words are interchangeable. So you'll know what axis to go on, and that helps us identify if it's the dependent variable, because remember that's what dV stands for, or the independent variable. Remember, the independent variable is what I, the scientist, have control over. Like, I can choose the amount of time that I want to measure the distance for. Am I going to do it for a minute, an hour, a year? The dependent variable, that's my data, D for data. What's going in my data table? What am I measuring? Okay, so how far whatever the object is has traveled. Okay, but notice distance versus time, that equals speed. You may have done word problems in the past and calculated speed when you worked on learning division. All right, so remember, we learn those math skills so we can put them to work in science class. Okay, so at this point, you should be comfortable with division and be comfortable with setting it up like a fraction. This is probably the hardest part for most people, is setting it up like this. But we'll learn the next class period we have how to do this and why we set it up like that, and how it's going to help us with our units of measurement and always getting the right answer. We will also spend some time clarifying the difference between speed, which is distance divided by time. So think about how far you traveled and how long it took. Okay, and on the speedometer in the car, maybe you're going 70 miles per hour. That's a speed because you're traveling 70 miles in 1 hour. We've heard this word velocity used in our normal conversations, sometimes interchangeably with speed. And that's not completely wrong, but velocity is better than speed. Okay, because speed, if I just say I'm going 70 miles per hour, no one knows where I'm going. But when I use velocity instead, it's got the direction. Okay, so maybe I'm going 70 miles per hour north because I'm on I-35 heading to Dallas. And it could be direction as far as like cardinal directions, north, south, east, west. This can be up, down. This can be left, right. However they are portraying that you are moving in a given way. Right, so velocity is better because it provides more information. Right, but notice it's the same math. We're just tacking on more adjectives, which is obviously better. Okay. Now for our motion graphs, what we're going to focus in on is looking at the shape and the slope. In your math classes, at some point, if you haven't already, you will learn to calculate slope. All right, but let's draw on some of our everyday life experience. Think about hills in your neighborhood, if you've ever gone skateboarding or rollerblading down them, or even riding your bike, and how that affects how fast you go or how much effort it takes to go up or down it, or skiing. All right, so draw on things that you know to help you out. And we'll revert a shape between, is it a straight line or a curved line? Okay, and all of this we practiced with our graphing games and our Stickman. So if you didn't do that, go back to the previous video and watch that and do the graph games first so that this will make more sense to you. Okay, so I'm assuming that that's already been done, you've already accomplished it, and now we're moving forward. Right? So we have a simplistic little graph here. Notice how we've written the x and the y coordinates, or sorry, the x and y labels. And go ahead and learn to write them correctly. Like little t means time. Capital T in science means temperature. So it's better to start doing it the correct way instead of having to break a bad habit later. On a lot of our Stickman things, he was going away from zero, right? So he had a positive slope, and we were moving him on that number line to the right. Okay, so on a graph, if you have a positive slope, that is indicating motion to the right, or motion away from the source. All right, so we're going to keep it real simple, but there are reasons why there's 4 quadrants to graphing. All right, we're not going to worry about any other quadrant, but just know that it will be more complicated. We're just sticking with basic left-right, okay, instead of the 360 kind of information. But this is what's known as a positive slope, because every point is higher than it was before. Okay? Don't confuse yourself between what the graph looks like and the path the person took. Sometimes you need to, take a step back and think about it in terms of the Stickman. If you have a downward slope, okay, this is referred to a negative slope. When you moved your Stickman back to the beginning, he was coming back to the origin, he was heading home. This does not mean he's slowing down. Okay, this just means that his distance is getting less, so he's coming back to where he started. Okay, so if it's this, motion to the right. If it's this, it's motion to the left. Okay, or away from the origin towards the origin. In all of these, they've had straight lines. Okay, so a straight line, when you learn to calculate slope, will show you that it's a constant velocity because there's not a change in the angles of the lines. And we talked about this a little bit before about cruise control when we talked about balanced and unbalanced forces. You can be balanced and on cruise control because it's in motion. Like if the car's on cruise control, it is in motion, but it's in constant motion. So like if you set the cruise control at 70, it's going to keep you going 70 miles per hour. So when you see a straight line, it's a constant velocity. However, sometimes we'll see something like this. All right, so this first portion, he was traveling to the right with a straight line. So at a constant velocity, he was traveling to the right. And honestly, these are not the most realistic graphs because think about getting in the car. You don't, get in the car, put your foot on the pedal, and immediately go 40 miles an hour, right? Plus there's the getting out of your neighborhood, getting on the highway. So these are very simplistic graphs. But at this point, it becomes a flat line. It is still a straight line. It is still a constant velocity. But this flat line means the distance has not changed. Right? So that means that there's no motion, the object has stopped. So he's still constant in his velocity, but his velocity is 0. So kind of a morbid way that we remember it is we think about this as if it was a heartbeat. Right? So like on a TV show or a medical drama, you've seen the EKGs of people's heartbeat. And when it goes flat, they're dead. So I know it's horrible, but it is a way to remember when the line is flat. See my little heart? That's an easy way to remember what is happening when the line is flat. Plus, you can always look over here, add some numbers to the graph if it bothers you. Just put like 0, 1, 2, but that means it's flat and not moving. Okay. We're not going to get too complicated with the curving lines. That's for a higher grade level, but I want you to be able to recognize that if there's a curve, that means it is not constant. Okay, so the straight line was constant, so if it's not straight, meaning it's curved, The velocity is not constant. Okay, stands to reason. What that means is acceleration, like we talked about with net force. Okay, acceleration only occurs when you speed up or slow down, which most people don't have a problem with. But don't forget about changing direction. Think about those people who drift in those race cars. All right, so you can change direction without changing speed. Not the safest thing ever in terms of cars, but think about airplanes. They don't halt in midair and suddenly turn to the west. All right, it would be problematic. So when you have these, it doesn't matter if it curves up or it curves down. These do signify different things, but you'll clarify that at an upper grade level. We're not worried about it. I just need you to identify if it's curved, that the object is accelerating. This means accelerating away from the origin or to the right. This means it's accelerating to the left. All right. So you've got this. When you have your notes done, you'll go here in Classroom and do the motion graphs practice, which is what the second page was that you made in your science notebook. So there's a quick 8 questions over this graph. All right, so most of them are pretty straightforward. Do not forget you have other notes from the past to use, like the variables. You have variables notes. When it's asking about the intervals for time and unit, don't freeze and panic. You have graph notes. Okay, and in your graph notes, it talks about an evenly spaced scale. So here with interval, we just have to get used to the word. Because interval or scale, what it means is what does it go by on that axis. So time's pretty simple. It's going by ones. Right? I'm helping you out. You're welcome. And if you look at distance, every line is worth 30. So that's what it means by interval. It's like, what are the lines going by? And it's supposed to be a nice, evenly spaced scale. Okay, so you'll do these practice problems in your science notebook. And then you notice I've posted the key. Obviously, don't look at it. Oops, I gotta put the file. Note to self. It will be there by the time you watch this, but the key will be there to check yourself. And if you got one wrong, go back, look at your notes, even if it's the parts of a graph or variables notes, and check it out. Hopefully you scored well. If not, try to fix it in your brain. Feel free to come to tutoring. And then you've got the motion graphs Quizlet, okay, that you can practice before I see you again. Remember, stick to the match and the gravity games, or the flashcards and the learn. Don't worry about the write and the spell. Like, those are very persnickety and it's just frustrating. Okay, so work on this Quizlet to practice that motion graphs knowledge. All right, so feel free to send me questions in an email or a message on Classroom and come to tutoring. Thanks.